Okay, well, Kalimera σε όλους. Apologies for delivering this presentation remotely, but I'm afraid it would be impossible to be with you as I'm attending an international conference of geophysical prospection at Kiel in Germany. I would like to thank Despina Tsiafaki and the rest members of GIS Athens for their invitation to deliver this presentation on their workshop hosted by the British School of Athens. The title of the talk is dealing with the polymorphism of archaeological GIS. Let me see. Okay, here we are. I chose a specific term in order to express the ability of archaeology to find its different variations, actual identities, through unfolding the fortune cookies of GIS functionalities. We have to stress, however, that this terminology does not follow the strict definition of biology, which makes divisions in sharply distinct forms. On the contrary, the different forms of archaeological GIS entangle the spatial tools of GIS with the theoretical and practical issues of archaeology. Back in 2014, together with Dr. Sylvian Deterix, we presented an article about historical evolution of the archaeological GIS applications in the Greek landscape. Since the beginning of Geostat Research Lab in Crete, namely in 1996, there has been a lot of effort to demonstrate the potentials of GIS in archaeology, and I'm really glad that this momentum has been caught by a number of research groups today. Independent of the applications that have been carried out, micro or macro, 2-dimension, 3, 4 dimensions, geostatistical or descriptive, locational or predictive analysis or monitoring, GIS has unfolded new dynamics in archaeological research, moving away from simple mapping, visualization, and geotagging to address challenging tasks of analysis that combine diverse geographic, temporal, environmental, climatic, and cultural datasets. Geospatial technologies have given a new perspective in archaeological science. We have all seen a number of applications spanning from the identification of settlement patterns, proximity studies and network analysis, site catchment, visibility studies, and numerous others, some of which we shall also hear today, together with applications in urban and landscape studies, in the context of excavations and surface surveys, 3D mapping, etc. Indeed, we learned how to use spatial analysis for approaching field observations and testing theoretical hypotheses. We use GIS to analyze archaeological data, but at the same time, GIS gave us further ideas of how to make new historical narratives. So, can we follow specific spatial recipes and guidelines to carry out our archaeological analysis? In other words, is GIS the answer to life, the universe, and everything in archaeology? Well, obviously not. We all know the answer, I guess. There are a number, though, of more challenging applications, though, and at the same time, we are facing a number of technological changes that have not left intact the archaeological GIS scape. The first of them concerns the increasing production accessibility of datasets. The evolution of archaeological GIS spatial modeling has unavoidably led towards a more interdisciplinary involvement of different sciences. On one hand, the technological advancements in remote sensing, including new sensors with higher spatial, spectral, and temporal resolution, airborne LiDAR mapping, drone multispectral imaging, landscape geophysical prospection, global navigation systems, or even the use of robotics, as in the case of the Land Air Sea robotics program at Johns Hopkins University that is using robots to collect data to be automatically analyzed through GIS, have enhanced the quality and quantity of the geospatial data. We have datasets that are created and produced daily from European, national, and local agencies. Just to consider the Copernicus program that delivers about 20 terabytes of geodata daily. And this is not all. There are data generated from personal devices, such as mobile phones, drones, digital cameras, portable LiDAR systems, and so on. Needless to talk about those collected by crowdsourcing applications, just to consider the example of the space program of Sarah Parsec. Thus, we are caught within the realm of data, images, and measurements with different degrees of accuracy, reliability, biases, and redundancies, offering, though, a vast number of possibilities. In the current digital ecosystem, it has been mentioned that we are going through a new scientific paradigm, which relies on data-intensive science. In the past, we have used to formalize a research topic through a linear project design. Nowadays, it has become usual to follow a data-driven design of research. Let us not forget that the creation and processing of the data is already a science, data science. We still need, though, to select the proper datasets, new or even legacy data, and find ways to process the big data coming from different sources. Despite the fact that we do have measures to check the original trends and interrelations of the original data through statistics or exploratory data analysis, most of the GIS practitioners in archaeology are not dealing with such kind of preparatory stages, but also testing of the results through different statistical measures, such as fuzzy matrix, hotspot analysis, or receiver operating characteristic curves, is necessary to provide a measure of credibility of the applied methodology and their dependency to the original data. Our dependency on the software packages is another issue, since most of the times the algorithms behind the black box are not clearly defined. For example, viewset analysis in QGIS does not produce exactly the same results as when carried out in ArcGIS or Idrissi. At the same time, we forget almost always to provide information about the produced outcomes. And okay, I mean, one can get information about the metadata from the images per se, but not about the paradata, namely the way of creation and use of the data, stressing the lack of interoperability of archaeological data or of the results of spatial processing. The second issue refers to our overwhelming reliance on the existing tools. For example, we are using the cost surplus analysis mainly based on the slope of the terrain and our favorite Tobler's hiking function, forgetting that there are other factors as well, such as the cognitive meaning of slope or the choice of routes following a visible or invisible paths, the weather conditions on seasonal basis, and others. Other alternatives, such as the focal mobility network, the from everywhere to everywhere analysis, or the spatial design network analysis, have been also proposed. But how can one be able to choose the best method of their analysis? The third point to be made is the one of integration of techniques. GIS is not to be used solely for landscape modeling. We can do a lot with it when we combine it with other types of analysis. Space index, 3D visibility, and acoustic analysis, just to name a few, can enrich the results of the well-established spatial analysis and provide a much better cognitive meaning to the results of spatial computations. I'm sure in this workshop, we are going to see some exciting applications of GIS landscape studies. Still, there are a number of difficult cases in landscape mapping. Just to take some examples, let us consider the deep mapping, which from the spatial humanities perspective refers to the mapping not of the physical space, but of the experiences and feelings perspective of the agents that have visited a place. It may concern the memories of a person for his own topos, or the narrative of giving meaning to the physical space through time. It is like we think of space as a static canvas that takes motion due to the relations, actions, and impressions of the people. The way to proceed in such cases is to decode the qualitative descriptions of the human agents and recode them again, connecting them to the spatial dimension of the landscape. This is actually the goal of one of our youth postdoc researchers, Cristina Mancetti, who, through the mapping of the itineraries of travelers in Cyprus and Sicily during their grand tour and analysis of their perceptions and experiences, she tries to study the role of the grave for antiquities in shaping a European identity. The modeling of maritime mobility is also another challenging case in archaeological GIS. The main difficulty is that on one hand, we cannot apply the conventional least cost path analysis, and on the other hand, its dependency on too many parameters such as the seasonal wind speed and their direction modeling, the wave height models, the sailing techniques, the sailing technologies, the environmental conditions, just to mention a few. It is obvious that each one of these variables influences the sailing times in different periods daily and seasonally. The sailing paths can be enhanced through the mapping of shipwrecks, harbors, and anchorage niches, as long as there are accurate coordinates, which is obviously not the case. Models make use of different sailing grids according to the wind intensity and direction, sequential least cost paths utilizing deterministic time series wind paths, or even cartograms depicting the warping of space to represent the speed of travel between regions at different seasons or time periods. Challenging landscape studies are also those dealing with archeo or paleo reconstructions of the terrain, either due to the sea level rise or due to tectonic movements, alluvial deposition, uplift or sinking of land associated to earthquakes, changes of river courses, or even of the coastlines. It is obvious that in tandem to other paleoenvironmental studies, such as the changing of the vegetation or the study of the microclimatic conditions in a region, can play a crucial role in the geospatial analysis, especially those dealing with locational and predictive modeling. And this brings us obviously to the chapter of spatial modeling and prediction, which is used as a means to investigate the spatial distribution of archaeological evidence in terms to the landscape environmental characteristics. On one side, we have the spatial pattern analysis techniques that make use of exploratory data analysis, including point pattern analysis, spatial autocorrelations, or cluster analysis. It is the results of spatial modeling that constitute the base upon which predictions can be made. Predictive models can be based on multi-criteria decision analysis or analytical hierarchy process models. Alternatively, they can rely on statistical techniques such as logistic regression, diffusion models, or maximum entropy modeling. There is always the solution of simulation approaches through the use of agent-based modeling, of course, which makes use of theory-driven modeling that approaches the human behavior in relation to the environmental and climatic conditions. But which is the best predictive model that we can use? There are a number of topics to stress here. First, there are not a lot of studies in comparing the outcome from different predictive model approaches. Second, there is a serious lack of implementation of sociocultural variables into the models. Notions of persistence of habitation in a specific location, the preference of moving along trade corridors using, for example, social network analysis, or in areas of high invisibility have not yet fully explored in predictive modeling. I think that we all understand the complexity of the above, which makes it extremely difficult to decipher the past human actions, especially when a large volume of data is involved. It is this particular reason that we have started to explore further the capabilities of artificial intelligence and machine learning algorithms in terms of different domains, and especially those datasets that have a geographical component. We have experienced their application through different classifiers, such as random forests and neural networks, in processing of archaeogeophysical data, drone, satellite remote sensing, and LiDAR imagery, and their capabilities in the automatic detection of archaeological features, geophysical feature segmentation, or microtopographical anomalies, which has been well demonstrated in the past. Despite the fact that some algorithm architectures like the UNet encoder has the advantage to operate with a small number of datasets, in most cases we are suffering from the small number of images that can train the algorithms to have a high degree of classification and prediction results. This is indeed calling for the creation of open databases with signatures from different geographical data. You can see, for example, an open access database that we have constructed in our digital humanities Geoinformatics lab at the University of Cyprus, that we have started populating it with geophysical data from different sensors for different sites, and we have geotagged them so that they are ready to be used by everybody in different machine learning architectures. So where do we stand? There are a number of graphs that try to map the development of technology through time. I just indicate a couple, the Gartner's hyper cycle and the crossing the chasm, because of different messages that they send. Archaeological GIS has followed the same Gartner's hyper cycle, even if it is not a cycle, as you can see, as the rest of the technological advancements of GIS. Its enthusiasts encountered successfully the opponents and skeptics. They understood its limitations and the need of specialized spatial tools that need to be adapted to the needs of archaeology, since we are dealing with the decision-making of human agents. So, has the archaeological GIS reached the plateau of productivity? Have we crossed the chasm, moving towards the mainstream adoption of the technology? Even if it is tempting to say yes, I have to argue that this is not the case. First, archaeology is following the development of GIS, whereas we need to have the advances of archaeological research to shape the GIS tools that we need to employ. This is one of the problems of the above graphs, as they do not account for the speed with which the research of technology develops over time, usually in a non-linear way. Second, most of the archaeology GIS practitioners are trapped within the dynamic field of the well-established tools, without having the knowledge to escape out of it and make use of more specialized tools that need better skills and knowledge of the topic. And this brings us to the chapter of education and training. Before we started our master and PhD program at the University of Cyprus a couple of years ago, we mapped the European education scape in archaeological GIS and landscape archaeology. There were so few programs focusing to the archaeological GIS in the whole Europe, which was a real surprise. I guess this is why we also joined forces with the University of Athens and Athena Research Center to create a similar but not the same graduate program. However, with respect to my experience from teaching GIS and spatial computational methods to archaeological students, I have to stress the following. Most students start from zero-level technical background or semi-knowledge of what GIS is. This means that we need to explain thoroughly the fundamentals of geospatial technologies, from projection systems to the details of how the different algorithms are operating. There is a need to go beyond the simple training and learning skills. They need to realize that GIS does not mean the simplistic usage of tools through which we can get colorful results and maps. In this aspect, they need to be well informed. And after making some progress, we need to take away the misconception that after 2 GIS courses, they know everything. They shall need to be exposed to even more specific applications and more sophisticated analysis. And most important, they need to think out of the box and make archaeological interpretations with a critical point of view and validate the results of their analysis. The final issue in this is that almost all educational programs are oriented towards training GIS practitioners. We need to decide what we need, though. Personally, I'm not comfortable with educating students to become GIS consumers. I want to see them becoming GIS producers, creators, and innovators, not technicians, but actually to improvise with respect to how archaeological theory and practice can modify, shape, and advance GIS tools. If we want to reach the plateau of productivity and cross the chasm, as we saw before, we definitely need to invest to our archaeology students with much more focus to what the new horizons are, instead of relying to the well-established spatial methodologies. It will be them to open the new frontiers of archaeological GIS. So where do we go from here? There are numerous papers dealing with the future development of GIS. They refer to the processing of big data, the cloud-based computing, new geoprocessing capabilities, mobile GIS, the fusion of augmented reality, virtual reality with 3D GIS, the real-time mapping capabilities. See, for example, the impact of mobile applications such as Pokemon Go that combines augmented reality with geographical locations in a gaming platform. I'm sure that Hector will talk about all this towards the end of this workshop. We're definitely moving towards a new generation GIS, but are we moving towards the next generation of archaeological GIS? Are we able to exploit all these capabilities, not just for demonstration, gaming, 3D reconstructions, touristic itineraries or others, but instead for addressing archaeological questions? Just to give you an example of sensory GIS, which is proposed so much from postmodernism. Let us assume that we make an application that approaches an urban historical center with 3D reconstructions of its buildings, the sounds that were heard during the period from the different temples or cafe places, the smell that could have come from the nearby bakeries and taverns. Yes, it will be perfect to have a more integrated, realistic vision of the period. But what archaeological questions does it address? What is the added knowledge that we are gaining out of it? So I will rephrase the original question. Where do we want to go from here? Obviously, do not expect an answer from my side. It is we that need to address this question, if not our innovator students that we need to support. I shall end this presentation here with a joke I asked from our recent friend ChatGPT about archaeology and GIS. And you can see, I guess, why an archaeologist was kicked off a GIS lab. Thank you very much.